All right. Good afternoon, everyone, and welcome to our session. I hope everyone's having an amazing re:Invent so far. So today afternoon, this is me, Aritra Gupta. I'm a product manager on the Amazon S3 team, and with me, I have Nikos from the S3 engineering team, and I have Somil as well from Zeta Global, and you'll hear from both of them in a bit. All right, so just to get started, right, if you're in this room, you're probably already using Apache Iceberg or are thinking of using Iceberg in production for your data lakes. So maybe just a quick show of hands if you're familiar with or you're already using Iceberg in some form or shape. Oh, wow, that's quite a lot of us. And maybe to take this a step further, right? Now that you have your data lake set up or you're thinking about it, you're probably also thinking about taking it to more than one regions or kind of replicating it, be it to share with your teams who are distributed globally or for compliance or for just a backup use case. And for those who've tried this, I think we all know that replicating Iceberg tables is a super hard problem. Because it's not just about replicating objects from one point to the other, but it's also taking care of Iceberg's metadata guarantees, making sure that we understand the spec really well, and then having your replicas in a read-only state that's easily consumable by your downstream applications. And typical customers who've tried this told us that it took them about 6 to 12 months to get a working application running. And then it also takes them additional time to maintain this infrastructure as the teams scale up further. And that's what we are set out today to solve for, which is how do we get to you a fully managed Iceberg replication solution that helps you solve for all of these problems. So with that, let's get started. Now, in the next 50 minutes, here's what we are going to cover, right? So first of all, we are going to see why do you even need a multi-region data lake in the first place. Then we'll talk a little bit about S3 tables. We'll kind of introduce the new offering, which is replication support for S3 tables, look at some of the use cases and workloads where you can apply them, and then we'll have Nikos walk us through the feature with a few demos. Finally, we'll hear from Somil, who's been using S3 tables in production throughout this year at Zeta Global, and how he plans to use the replication support as they grow into multiple regions. So with that, let's get started. Now, first up, let's talk about why do we even need multi-region data lakes in the first place. And there are three key drivers that we've heard from multiple customers. The first one is performance. Now, imagine that you have data scientists based out of Singapore, London, and New York, and while you have your data sets in US East 1. Now, your data scientists in Singapore will definitely say that their queries are much more slower. Well, basically because the data is traveling all the way over the Pacific. And on top of it, each query made by them will also result in additional inter-region data transfer costs. And in this scenario, it makes a lot of sense to have your data sets closer to where your users are. Next is compliance. Now, for those of us who are in regulated industries such as healthcare or financial services, it's almost always a requirement to have another copy of your data isolated from a primary copy. And this could be for resilience, for disaster recovery, or any other mandates out there. In fact, there are some regulations that need you to have another copy of your data totally isolated from the primary, and they require somewhat about at least 500 miles or more. And they also need it to be encrypted differently. So that's another common use case that comes up. And finally, data protection itself. Now, I'm sure all of us are thinking, well, Iceberg gives you time travel capabilities, and it's easy to roll back to a previous version, and that's all true. But however, we've also seen customers run into those days where someone accidentally just drops a table or drops an entire database worth of tables, and there's no good way for you to get back to that previous state. Or additionally, you might also want to protect yourself against ransomware attacks or any other kind of malicious activities. So in all of these scenarios, you do want to look at having another copy of your data or replicate your data lake into another region. Now, before we dive further, I want to briefly talk about how Iceberg works. It looks like all of us are pretty familiar, so I won't go too much into the depth. But at the very bottom, you have your Parquet files, which are containing the actual rows, containing the actual tabular data. On top of it, you would typically have your metadata files, which basically make up the Iceberg spec. So this could be manifest lists, manifest files, metadata JSONs. And on top of this, you would have the query engines and the catalogs. So you can use any query engine of your choice And that's why we all love Iceberg, right? You can use Spark, you can use Trino, you can use Athena or Redshift. And because Iceberg is made up with these multiple layers, that's where replication becomes a little more challenging. And to kind of outline this, I want to walk us through 3 ways in which customers replicate Iceberg tables today. Now, the first way that customers would do it is simply use S3 replication. Now, what happens in this scenario is you take your source bucket, source files, and you turn on S3 replication, or you physically replicate copies into the replica tables. Now, there are 3 big challenges that come up when you're using this approach. First one is, because S3 replication is asynchronous today, you need to figure out a way to understand whether snapshot 1 has arrived before you go and commit snapshot 2 to your destination. Similarly, there might be a scenario where your metadata files have landed before your data files can land, and that way your queries at the destination may not be useful. Second problem, which is kind of peculiar with Iceberg, is all the metadata files that refer to the data files underneath have absolute file paths embedded within them. So for example, it typically would start off with S3/ your bucket, and then the path to your exact key itself. What that really means is that you need to now have custom logic to transform them and point to your destination buckets themselves. And finally, all of this is happening at the storage layer itself. That means you need to coordinate with your catalogs, and you need to coordinate with your higher-level applications to make sure that they are aware of each of these commits that you're replicating on the other end. So once all of that happens, now you have a queryable replica on the other side itself. Now, some customers take an alternate approach, where what they do is they have a source table, and then they run custom ETL jobs or Spark jobs, where you would have every logical snapshot that's written on the source get replicated on the destination. Now, with this approach, there are 3 key considerations that customers need to think of. The first one is your jobs need to be aware and track state of the snapshots or the commits that have been replicated in the source. So for example, if you run this hourly, you want to make sure that you have snapshot. If you caught up till snapshot 101, you want to make sure that the next time you run, you are looking at all the snapshots on top of it. Second, you need to think through how you are handling error scenarios, and how if some objects were successfully replicated versus others were still kind of in flight, how do you handle those error scenarios itself? And finally, these jobs need to be really smart to understand Iceberg spec, and let's say you have a schema evolution on the source, or you did some sort of hidden partitioning on the source tables. You want to make sure that all of those updates are also getting accurately replicated on the other end. And the final one is where customers look at a single application doing dual writes on both these tables. Now, the obvious design challenge here is kind of appearing here itself, where essentially you're putting your replication infrastructure on the critical path of your applications. And this has its own implications to think through, right? Now, imagine that you need to get an acknowledgement from your writer. Do you do that when your source is replicated, source is committed, or do you do that when both your source and replicas are committed successfully? You also need to think through latency, you need to think through performance, and finally, a lot of Iceberg writers may be used to writing only one region and one catalog at a point. So you need to make sure that all your applications are wired to write to both these regions at the same time. Now, all of this is not just theoretical. In fact, we had a customer who successfully built this, where they were replicating petabyte-sized data lakes from region A to region B. And you can see how complicated this can get, right? So for example, they used S3 replication to move these objects from region A to region B. And then on top of it, you have a DynamoDB global table that's kind of understanding and tracking the state of these replicas as you move them forward. And there's a bunch of Lambda functions, CloudTrail, S3 inventory, and other stuff that goes under the hood to make this successful. So while they were able to get this, we hear this from multiple customers who want a simple and easy way to replicate their tables from region A to region B. So with that, I just wanted to make this my mic drop moment, where we want to talk about this announcement that was made yesterday, which is replication support for Amazon S3 tables. Last year, we announced S3 tables as the easiest way for you to get started with Apache Iceberg in the cloud. And this year, we kind of take it a step further, where now you can have multiple copies of your data lake within a few clicks. And to add to it, this is not just simple object replication with Iceberg bolted on top of it. But as we go through my talk and the demos and how all of this works, you'll see that we build this from the ground up, where we've really taken into account how Iceberg works. And working backwards from your requirements, we build this replication feature in the first place. So let's talk about this new concept of a read-only replica. Now, every time you set up replication on either a bucket, where we want to replicate all your tables, or you selectively choose tables that you need to replicate, the service creates something called a read-only replica. And it has 4 key characteristics that I wanted to highlight. First up, these replicas have the same namespace and table name as the source. So what that really means is you can easily point your applications and queries to just point from the source bucket to the replica bucket, and it's super simple for you to reuse all your queries. Second, we take care of replicating everything the moment you tell us that you need to replicate a particular table. What I mean by that is we backfill all the current snapshots that are in your Iceberg table, and we also make sure that we take care of any ongoing updates that are happening on your table once you turn on replication. Third, we understand Iceberg data and metadata natively, and we understand each part of the Iceberg spec. So what that means is when you evolve a schema or when you have any other changes to your metadata as well, all of that gets propagated in the right way to your replicas. And finally, all of these read replicas are always query ready. So what that means is you don't need to worry about how do I point my applications? Do I need to have a different kind of RTO, RPO requirements? As soon as you point these applications to the replicas themselves, these are query ready. Now let's talk a little bit more about what this feature really gets you. Right? So with native replication support out of the box for S3 tables, you can simplify your operations, you get the scale and flexibility of Amazon S3, and as I mentioned, this is purpose-built for Apache Iceberg. Now let's look at each of these in depth. So the first one is around just simplifying your operations and how can you get rid of all the heavy lifting that you need to do to make your data lakes multi-region. So the first thing, as I mentioned, is you can just, within a few clicks and within a few configuration files, you can replicate all your tables within a bucket. And alternatively, you can say, hey, I have some production tables, I have some critical tables, and I just need to replicate those, and we'll take care of that as well. Second, you get out-of-the-box auditing and monitoring. So any tables that you replicate, anytime S3 replication replicates an object from a source table to a replica table, you get a CloudTrail log. Additionally, we also share the status API, which essentially tells you how far along the replica is from the source and what changes are in flight. It also gives you update in terms of the latest metadata file on the replica that you can cross-validate with the source itself. And finally, all of this comes with the out-of-the-box integration with native AWS analytics services. So it's still the one-click integration with the Glue data catalog and lake formation and the unified studio on top of it. So that makes it super simple for you to just spin up your data lakes in another region and have applications on top of it and running. All right, next I want to highlight a very interesting stat, which is today, Amazon S3 replicates more than 150 petabytes of data every week across regions. And the reason why it's interesting is the whole S3 tables replication support is built on top of this. That means we are ready for your data lakes of any size and kind. So you can bring in petabyte-sized data lakes, you can have tens of thousands of tables, and we will replicate them out of the box. Now, the more interesting part of this is not just the scale, but also the flexibility that you get out of it. So I wanted to highlight 3 ways in which you can make your replicas really customized and useful for your individual needs. First one is storage class. So you can have your primary tables be in standard storage class if that's what's needed, but in case you want your replicas to have more cost benefits, you can have them in intelligent tiering storage class. In fact, we just announced intelligent tiering for tables as of yesterday itself. Second, you can have separate and independent retention policies for your replica tables. So for example, you could have your source table be retained for 7 days and a number of snapshots, versus you could have your compliance backups be for 90 days, and you can have your archival replicas be all the way till 7 years. And snapshot expiration works independently for each of these replicas as you configure. Finally, you can choose your own encryption key that's separate from the source table so that you have a more improved security posture. So all of these things help you create a very simple replica based on your needs. Now finally, let's talk a little bit more about how this is purpose-built for Apache Iceberg. The first thing, as I mentioned, is this is not asynchronous replication. What we really do here is we understand the sequence in which your commits or your tables were updated in the source, and then we apply the same sequence as we replicate to the destination. So what that means is snapshot 5 will always appear after snapshots 1 through 4 are replicated. Second, we make sure that when we are replicating the metadata files, all the paths where we refer to the data files themselves are transformed and point to the replica bucket. And this is a huge simplifier because we know today customers spend a lot of custom code making those transformations as you move the metadata files. Finally, a very important part of this is the way we want you to think about replication support is this is not just a blind copy of your metadata files. In fact, what we do is for each table update that you make, we understand what that update really means and then merge them safely on your replica. And that is how we are able to keep longer replicas, which can be there for 7 years or longer, while your primary is just, let's say, 7 days, because every time you write to your source table, we understand what that delta really means in terms of Iceberg parlance. And finally, we replicate both Iceberg v2, which is most commonly used right now, and also v3 tables, which was just launched by S3 Tables a couple of weeks back, and we support both of these versions out of the box. With that, I want to briefly touch upon some of the use cases and where you would use these capabilities. Okay, so let's look at a very common scenario, right? Let's say you are a financial services company and your data lake is in EU West 1, and this is where all of your transaction data lands. Now, let's say a few years down the line, you've started to now scale globally. So now you have teams in London, Mumbai, you have in Cape Town, and all of them require access to the same data, and they want to run training models and they want to do another kind of analysis. And what you can do here is you can really fan out your applications, where you can have all of your data collected in one region and you can replicate them to one or more geographies of your choice. Now, the inverse of this is also an interesting use case that we discovered along the way. So imagine you are a supply chain company and you have different components being manufactured at different areas of the world, and now you want a centralized platform because in Seattle is where all of your data scientists live. Now you want all the data to be aggregated towards them. And what you can do is you can generate all the data closer to where your supply chain factories are located and replicate all of them to Seattle itself. Okay, this is about how you can get better performance, lower latency, and better costs of your overall multi-region workloads. Let me spend a few minutes talking about data protection. So let's say we have a primary and you have a replica, and what you say is, let me commit a new and update to the primary. So as expected, we do replicate it to the other end as well. Now let's say the next command that came in was, let me expire my snapshots S0 and S1. In this case, the replication service does not take action on that. And that is because we know that while you expired your snapshots on the source, the replica will have its own independent snapshot expiration policy. Now, how this is helpful? Now, imagine you run into a scenario where you now need your old data back and you had accidentally ran that expire snapshot command. In that case, what you can do is you can easily have all of your data being read through the replica, and that will help you get back to the state that you were before. Now, moving on to the next use case, as I mentioned previously, you can think of these as multiple replicas serving different use cases. So for example, while your primary table is short and it needs to be performant, you can have your operational replica be slightly longer, and you can have your archival tables be as long as you need them to be. And finally, for all of us who need to meet those compliance requirements, you can imagine these tables being isolated in 2 different regions. We also do cross-account replication, so these could be 2 different accounts altogether and encrypted completely differently. So with that, I'll pass it on to Nikos to show us some demos and how this really works.
Thank you, Aritra. I'm Nikos, and today we're going to see together something really interesting, how to replicate S3 tables across regions and across accounts. So we're going to look into 3 specific demos. The first one is how to configure table replication and how to backfill your existing data from the source to the replica. The second one is about replicating ongoing updates, new records that land in your source table. We're going to look here also into how to monitor replication with the API that Aritra just mentioned. The third one is the most exciting in my opinion, which is a real-world scenario about centralizing data for analytics, and we're going to look into some interesting queries. After the demos, we're going to take a look into some interesting challenges that we faced while designing this new S3 tables feature. So let's dive into the first demo. So our case study here is that Aritra and I are building a new startup for e-commerce. So we have a mobile app which is storing transactions into our conveniently named transactions S3 table. This S3 table is in the source table bucket because that will be the source of our replication. Now, our use case is that Aritra wants this data to be closer to his AWS region where he's operating to generate some analytics. So let's take a look at what data exactly we have in this transactions table. We'll select the count star in Amazon Athena. And we have exactly 100 transactions in the table. Let's see how many Iceberg snapshots we have in the table. 10. So it's very convenient. We have 100 rows, 100 records across 10 snapshots. So now we're going to replicate that. So let's take a look how to replicate it. We'll go back to the source table, which is transactions, click on it, and go to the new management tab. Here we can define a table replication configuration to replicate exactly that one table. We'll click on Create Table Configuration, Replication Configuration, and here we'll specify the parameters. The first one is what is the destination table bucket. We want to choose Aritra's table bucket, which is destination, conveniently. We'll submit this choice. And then we'll choose an IAM role that replication will use to replicate our data. This role contains permissions for the source and the destination table bucket. I have already created a role, so I'm going to select it here. And then I'm going to submit the replication configuration. So basically 2 parameters to set it up, the destination and the role. So now we have already created it, and we see an updated management tab, which contains the parameters that we have just set. And if we press the refresh button, it will show us the pending status. Pending status means that there is an ongoing replication happening right now. What exactly that entails? The first one is that the replica table will be created in the destination table bucket we specified. The second one is that as soon as that replica is created, the data that exists in the source table will be replicated to the destination. So then you will ask, what exact data is replicated? It is the current active commit, which contains all the active snapshots. So we maintain queries and time traveling capabilities from the source to the replica. So now it's been a few minutes, and let's go and press again the refresh button, and we'll see that this status pending will have changed to completed. As soon as we click on the completed, we will see a pop-up which shows a timestamp. That timestamp represents the moment exactly when the replica got in sync with the source, when the replication was completed and all our data is present in the replica. So now all the schema, all Iceberg files, all data is in the replica. Let's go and see it. So I showed you before Amazon Athena. And I really like it personally because it has the same name as my hometown. However, Aritra really likes terminals. He's an engineer at heart, I think, even as a product manager, sorry. So let's go and connect InductDB to his destination table bucket. So we will attach the one called destination, and let's see how many snapshots we have transferred, we have replicated to this table bucket, and specifically the transactions table. 10, exactly as many as in the source. Let's see how many records we have. You remember we had 100 in the source. Perfect. We have a perfect match. We have 100 records across 10 snapshots. So we have the replica fully in sync with the source. We can continue running our queries against the replica now. So now, let's take a deeper look into these snapshots. On the top, we have the 4 last snapshots of the source table, and on the bottom of the replica. Take a look at the first 3 columns: sequence number, snapshot ID, and timestamp. Those are exactly the same between the source and the replica, because replication maintains exactly the same values. But now take a look into the manifest list location. You will see that in the source, we have a specific S3 storage location, while in the replica, we have a different one. That is because the storage locations are related to the context, which is the source or the replica. The takeaway here, the super interesting takeaway, is that replication will do this for you. It will rewrite all file paths inside Iceberg files, so in manifest lists, manifest, metadata, JSON, and so on, automatically for you, and you need to take no action at all. So we see that all the manifest lists here are updated already by replication. So now let's go and see some other case. Our application is being used by our customers, and now they are actually creating more updates. Let's see how to replicate those updates. So we'll simulate exactly that scenario. We'll insert one record in Amazon Athena in the source table. So let's go and do it. We'll insert a guide to using ST tables replication. Why not? As you will see, this will be automatically replicated. We have already set up replication. It's active, which means that any new record, any new snapshot will be automatically replicated. Let's see how many transactions we have after inserting this one. One more, 101. And how many snapshots? 11. So we have one new snapshot, one new transaction, one new record in the table transactions. So now, let's check the status of this replication. We have taken no action. We're just taking a look at the status with the new API. So get table replication status. We're going to come back to this API, so for now we just want to see the status, which is completed. Perfect. So this status is exactly the same that we can see also from the management tab of the AWS console. You will see here that when we refresh, we'll see again completed, but if we take a deeper look, we'll see a different timestamp. That is the timestamp when the new snapshot was replicated to the destination. And as a matter of fact, the status would flip to pending and then again completed every time you have new data in the source. So then you can query your replication progress in real time. Now on to the destination. We had 10 snapshots, if you remember from before. Let's see that we got the new one. And there it is, snapshot 11. So we have now exactly the same data in the source and destination. We can continue again running our analytics. Aritra is happy, I think. So let's move on to another topic. So we discussed about this get table replication status. Let's take a deeper look here. So we said that first, this is equivalent to using the console, but it gives us some more data. And why this is important. So we ask for the table replication status on the level of the source table. So you see that the parameter and the result here includes the source table ARN. For every table, we can have more than one destinations. So here we get a list of all the destinations with data for each of the destinations. So it can be that the status that we see here is completed for one destination, but in progress pending for another one. So we'll get the full information there. We also see the information about the configuration that we set, what is the table that we are replicating to, and what is the table bucket, and also what is the last update, which, if you remember, that was the timestamp that we saw on the console. Here we see additionally what is exactly the metadata location of the last metadata JSON. Okay, so let's go ahead and see the most interesting use case. in my opinion. So fast forward a few months, our startup is expanding. So now we have customers across 3 continents, Europe, Asia, and Australia. The interesting part of this is that we store the data in 3 different AWS regions, but Aritra wants to perform some analytics, wants to run some queries in a combined data set. So how are we going to combine it? We're suggesting here actually to combine it by replicating all the data into the region closest to Aritra. So we're going to replicate it to one region in North America, for example, US East. And let's see exactly how we're going to do that. So this is the data that we're working with. We have 3 table buckets: e-commerce Asia Pacific, e-commerce Australia, e-commerce Europe. Now, let's take a look exactly what we have in these table buckets. We are going to open the first one and see what tables we have. So we have orders and order items in a parent-child relationship, a very typical setup. We don't want to set up replication for each one of them again, because we don't want to run this configuration twice. So what we'll do this time is to go to the Management tab of the table bucket. This will configure replication for all the tables in this table bucket. So let's go ahead and do it. As you can see, the configuration is exactly the same. You choose the destination table bucket, which in this case is in another region, and it's called e-commerce analytics. We'll submit that. And then, of course, choose the replication role that we have already created. Again, we'll create the replication configuration. And now we're back to the management screen where we see the basic information for that. So now, I've done exactly the same process off the screen for the other remaining 2 table buckets. So we're not going to spend time on that. But we're going to spend time to see what exactly we have on the replica. So now we have replicated all the data from 3 continents into one specific table bucket. So let's go back to Amazon Athena and see what data we have there. But first, you may ask me, how do we differentiate between orders and order items of each of the 3 sources? Don't they conflict when they get merged into the same table bucket? The answer is no. And why is that? Because we used S3 tables namespaces to differentiate the source from which the data is coming. And we're going to see this exactly in action now. So let's take a look into this database dropdown. It has 3 values, which are the namespaces that we defined. We can use exactly those namespaces as identifiers in the query in order to define what data we want to actually pull and generate analytics from. So let's take a look into some interesting queries that we can run here. The first one is showing us our top product categories. Actually, where do we perform the best and where should we focus next? And here we see per continent, per region, the categories, revenues, orders, and so on. It's just a typical report that we can run. The second one is about regions and how exactly they perform. So how did our sales go in Europe, in Asia, Australia, and so on. And here we see sales, we see customers, average order values, and we can actually aggregate all sorts of data. This is just a sample. The last one is about payment methods. So let's see, for example, which payment methods do best, where exactly our customers are leaning towards, and where should we invest next, what exact collaborations we should do. So here we see bank transfers, mobile payments, amounts per payment method. But basically the point is, these are some very basic queries that you can run on top of S3 tables. And when it comes to analytics, the sky's the limit. So basically you can run whatever you can imagine, but what you need to remember here is that this is powered by S3 tables replication in order to centralize these datasets and execute those analytics in one specific location. So now let's move on to some interesting challenges that we faced. This is slightly more technical, but not too much. We'll try to keep it a bit high level for everyone. So the first one is about snapshot ordering. You may know that Iceberg snapshots are not independent. So snapshot 2 has to come before after snapshot 1, because its parent is snapshot 1, and snapshot 3 has to come after snapshot 2. In traditional data terms, imagine it that snapshot 1 is creating a record, snapshot 2 is updating that record. Snapshot 3 is deleting that record. So you can never replicate, for example, snapshot 3, the deletion, before the update or the creation. That doesn't make sense. If you do that, you will actually corrupt the replica. You will not be able to execute queries or even time travel. So the question is, how do we solve that in a strict tables replication to replicate everything in order? So we base everything around sequence numbers. Every snapshot has its own unique sequence number, and they are monotonically increasing. So we validate the sequence numbers. We never commit a snapshot before it is its time to be committed, its order to be committed. We validate and enforce the parent-child relationships for snapshots, and also commits to be committed in chronological order. And last, the bonus one, we coordinate concurrent writes. This is a slightly more interesting one because it is the topic of the next slide. So let's look into concurrency. So what we do is that, like Aritra mentioned, we don't just copy blindly the metadata JSON from the source to the destination. We cannot do that because metadata JSON has fields and information that is context-specific, like replica-specific or source-specific. Let's take it with an example. You want to replicate a source table to a destination, to a replica. Replication is not the only actor acting on this path, on these tables. You may also have your retention policies executed by strict tables maintenance. And let's take an even more concrete example to look into this. So you have a source table. When you create source snapshot 1, it will be replicated as snapshot 1 in the destination. That is almost a direct copy if you don't think about paths. Then you may have snapshot 2, also replicated. But then, if you expire snapshot 1, then source and replica have diverged. So you have to be very careful and very context-specific and aware when you make any sort of operations for replication. So when you replicate afterwards snapshot 3, the replication process will have to assess the state of the source, assess the state of the destination, and make sure that it does not remove snapshot 1 when the incoming metadata JSON actually does not have it. So that is why we actually merge. We assess the state of both, and we take very informative decisions. So now, what exactly we do? Let's take a look. We classify the metadata JSON fields, all the information, into 3 categories. The first one is historical data. Historical data, firstly, is preserved in the replica, and second, it has to be specific to the context, meaning that the snapshot log, metadata log schemas that we retrieve from the source, they have to be evaluated against those at the destination before we actually commit to the destination. The second one is the fields that are synchronized from the source, which are basically transferred directly from the source. And those pertain to the active state of your table. So for example, what is the current schema, what is the current snapshot, and so on. The last one is those fields that are modified on the replica level because they only relate to the replica. Those are the file paths or storage locations that we saw in many incidents so far, which we update, all of them, so they are valid for each of the destinations. If you have a source and 5 destinations, for example, each one will have its own file paths rewritten. The last one, of course, is catalog, which, of course, in the destination, it may be a different one. So that concludes our interesting challenges section. And next, I'll hand it off to Somil to take a look into how exactly they're using S3 tables.
Thank you so much, Nikos. Hi, everyone. Let me introduce myself to the audience. I am Saumil Shah, a lead software engineer at Zeta Global. Let me tell you more about our company. Zeta Global operates an AI-powered marketing platform that helps large enterprise acquire, retain, and grow customers. The company's mission is to make sophisticated marketing more simple and effective by leveraging artificial intelligence and large consumer proprietary data set to generate a high return over investments for its client. Now let me talk about the AI-powered marketing platform. The Zeta marketing platform makes marketing simple and more effective by bringing everything into one place, from knowing who your customers are to understanding their behavior to taking action. Let me talk about the ZMP platform. It's built on 3 core pillars. The first pillar is the identity. We operate at a scale of 245 million US consumer profile that lets us deliver a highly precise identity resolution. Next is the intelligence. We ingest over 1 trillion consumer signals on behavior, location, purchases, websites, social activity, and much more. This guides our AI to find the best marketing strategies for you. And last, the activation. We enable a true one-to-one engagement across all channels, helping marketers measure, optimize, and improve result. Zeta is the only platform that unifies everything into one single place. Zeta Global today has about 10 petabytes of data across their data lakes and data warehouse. We ingest close to about 6 terabytes of data every single day. And this data is returned into 10,000 Iceberg tables supporting multi-tenant workloads. Our dataset is growing by 40% year over year, increasing the pressure on our current pipelines. Traditional pipelines could not keep up with the combination of high ingestion volume and a need to deliver insight under 10 minutes, which is why Zeta Global has adopted Amazon S3 tables, which gives us predictable performance on extremely large Iceberg workload, reduce data freshness by up to 80%, and enable faster and more reliable analytics without re-architecting the entire platform. Now let's see how Zeta Global manages multi-tenant data ingestion into S3 tables. Every month we handle close to about 185 terabytes of data. That translates to about 250 GB every single hour. All of this into 10,000 Iceberg table under 10 minutes. So let's take a look at the solution. So we have a people service which manages user profile, which uses Aerospike as an OLTP database. This service processes 50,000 writes per second. All of this will generate a lot of amount of CDC events. These events are captured into the Kafka topic, and then the Kafka consumer would read these messages and would dump into the S3 bucket partitioned by the tenant ID. Next, a step function workflow runs every single minute to check if there are any new data files. If there are new data files, the system will acquire a log to ensure other system cannot process the same data simultaneously. The workflow then reads the data in a distributed fashion and submits job to the EMR as shown in the diagram. Let's take a deeper look at the orchestration on how we orchestrate these jobs. So the first step is the log acquisition. So before initiating any ingestion, the system will first acquire a log. Second, we partition the data. After acquiring the log, the system partitions the tenant data into different buckets, as you can see. Next, we submit the Spark job to the EMR cluster, and we use an async callback pattern. Once the job is completed, it responds back to the step function. Any failures that are captured by the step function will retry for 2 times, and then it will clean up any orphan files that are left. Here is how we use S3 table replication feature. We operate across US, Europe, and Asia, but our primary Iceberg tables were centralized in one region. With S3 tables replication, we now maintain a region local replica of our core dataset. A region local replica allows our customers to be served from the nearest region, reducing the network latency. Now, hand it over to Aritra.
Hey, thanks, Amil. All right, so just wanted to quickly recap all that we covered today. I think we still have some time for Q&A after this as well, if you're interested to learn more. But the key takeaways here, right? Essentially, as I mentioned, last year we offered S3 tables, which is a very simple and fully managed way for you to get started with Iceberg. And we expand that with replication support, where you can do same region, cross-region, same account, cross-account. You can create copies of your data, replicas of your data for various purposes. It's very simple to set up, as Nico showed, and it's easy to audit and monitor. And there are some best practices around how you would want to think about these replicas in terms of how you want to encrypt them, what storage class, and how long do you want to retain them at the same place. And finally, I really encourage all of you to take a look at our console, take a look at all of the various Iceberg applications out there, be it DuckDB, be it Spark, Redshift, and just give this a spin. Additionally, I just wanted to highlight a few more sessions that we have as we wind up reInvent. So tomorrow, one of my teammates, Adi, is going to present how S3 tables work, some of the best practices, so that can be an interesting session as well. And then we have a chalk talk where some of our other engineers and team are going to dive deeper into the overall S3 tables plus SageMaker architecture. So with that, I really thank you for joining us today, and I hope this was helpful. And yeah, excited to see all of you try out the feature. Thank you.
Thank you.